going to continue with Chapter 5 today on ionic compounds. And ionic compounds are formed through the transfer of electrons, one or more electrons. One atom loses, forming a cation. One atom gains, forming an anion. And we've already talked about how to write chemical formulas and how to name ionic compounds, both those that are binary ionic compounds and those that contain more than two atoms, those that contain polyatomic ions. And hopefully you have a high comfort level with that at this point. This learning goal will also swing into Chapter 6, which we'll get into end of this week, beginning of next week. And again, remember, you'll be quizzed on the naming and formula writing, as well as writing electron configs for ions. And the other piece of the quiz, which is really two quizzes in one, or 1.5 quizzes in one, is going to be on oxidation numbers. So we're going to start with oxidation numbers today. This is the trickiest part of the chapter. It's very mathy. It's basic algebra, but you have to be able to solve simple algebraic equations. Oxidation numbers are numbers assigned to atoms in a polyatomic ion, a compound, a free element, a monatomic ion, based on the assumption that electrons are transferred completely. Oxidation numbers can be negative, positive, 0. They can also be fractions. I'm not going to touch the fractions this year, but they are written plus or minus, then the number. And be careful between the difference of charge and oxidation number. For example, if you have a sulfide ion, its charge is 2 minus. Its oxidation number is -2. So oxidation number is always plus or minus, then the number, unless you had 0, and it would just be 0. So this is the charge, this is the oxidation number. So it's a number that's assigned to either an ion, a free element, all the atoms in a compound. For example, if you had a free element that is an element on the periodic table, or a diatomic element, this is going to have an oxidation number of 0. If you have a polyatomic ion, such as a sulfate ion, I'm going to teach you how to determine the oxidation numbers in a few minutes, but you'll see that sulfur's oxidation number for sulfate ion, sulfur's +6, oxygen's going to be -2, and I'll show you all the rules to determine that. So oxidation numbers are going to be plus or minus, then the number. So those are oxidation numbers. They help explain how electrons are distributed among atoms that are linked together in a compound, a polyatomic ion, etc. There are many guidelines or rules to assigning oxidation numbers. We're going to go through the rules now, and then we'll do a whole bunch of examples, and I think you'll have a pretty solid understanding of it. It says the oxidation number of a free element is 0. Any element off the periodic table has an oxidation number of 0. Doesn't matter where it is on the periodic table: calcium, magnesium, lithium, aluminum, sulfur, etc. 0. Any diatomic element, and you'll see this spells Brinkelhoff. It's good to know your diatomic elements. They're going to come back again and again. It spells Brinkelhoff. These elements, when by themselves, always come as a pair. If they're part of a compound, you don't assume there's a 2 there. You use your formula writing rules that you've learned. Polyatomic elements, where you have one atom but multiples of it, those also have oxidation numbers of 0. The oxidation number of a monatomic ion, a single atom, but there's a charge, so it's an ion, is equal to the charge. So calcium ion has a charge of 2+, an oxidation number of +2. Lithium ion has a charge of 1+, oxidation number +1. Sulfide ion has a charge of 2-, oxidation number -2. Tin can form a tin 2 or a tin 4 ion, oxidation number of +2 or +4 respectively. The more electronegative element in a binary compound is assigned the number equal to the charge it would have if it were an ion. This is the trickiest of the bunch. Your trend for electronegativity we introduced briefly in the last chapter. We said as you go across the periodic table from left to right, the electronegativity increases, with fluorine being the most electronegative element on the periodic table. As you go down a group, the electronegativity decreases. Values for electronegativity are provided on the back of your periodic table. You want to know the trend, but you could always check which is the more electronegative element from the back of your periodic table. I feel like this is stuck. And I clicked it, but it got stuck. So if you look at the back of your periodic table, you will see electronegativity values, and I apologize, I wanted to pull this right off the screen. I know there's a glare with this. Electronegativity of hydrogen is 2.2, lithium 1.0, beryllium 1.6, boron 2.0. You can see as you go across the period, here's the second period, the electronegativities are increasing. As you go across the period, the electronegativities are increasing. If you compare group 1 elements such as lithium, sodium, potassium, you can see the decrease in electronegativity. So those are provided to you. Word is stuck, so I'm going to continue to work through these with you. I may be able to reopen it. Give me a sec. I apologize. It just got stuck. Go ahead, I'm listening.
For the monatomic ions, is it necessary to put like +2 and +1? Like, you know how you have to put -2 to show that's like negative?
You mean for oxidation number?
That's it. You get to put the plus sign there.
Oh, if it's positive? Well, for a charge, 2+ would be essential, but in oxidation number, you do put plus. You are better off putting plus. It makes it easier for you. So in regard to this one, it says the more electronegative element in a binary compound is assigned the number equal to the charge it would have. For example, I give you ammonia, NH3. You'll be using ammonia in your lab this week. Many of you use it in your homes to clean. Which element's more electronegative, nitrogen or hydrogen? Nitrogen. And if you had a nitride ion, what's the charge on a nitride ion? Group 15. 3- is correct. So nitrogen's more electronegative, and if it were by itself, it would have a 3- charge. So the oxidation number of nitrogen here is -3. I'll show you how to determine hydrogen in a little bit. If you had nitrogen monoxide, which is more electronegative, the N or the O? The O. And oxide ion has what charge? Group 16?
2.
So the oxidation number of oxygen here is -2. Nitrogen, you'll see in this case, is +2. Most of your nonmetals have the ability to form multiple oxidation states, and we'll be taking a look at that. What you are going to learn shortly is for a compound, the sum of the oxidation states algebraically is 0. So if this is -3 and you have 3 hydrogens, you could figure out that hydrogen is +1 in this compound, oxidation number. Same thing here. If this is -2 and the sum has to be 0, what would N be in this compound? +2. And that's what we're going to get into in just a few minutes. That, to me, is the trickiest rule. The oxidation number of each hydrogen atom in a compound is +1 unless you have a hydride. If you have a hydride, you will have a metal and then H. So, for example, in water, the H is +1. In hydrogen chloride, the H is +1. In ammonia, the H is +1. But these are hydrides here where you have a metal followed by H. So for those, the H is -1. And there are a lot of rules here. You'll have the rules right in front of you as you work through initially. The oxidation number of fluorine in a compound is always -1. It's the most electronegative atom. So HF, the F is -1. Calcium fluoride, the F is -1. Aluminum fluoride, the F is -1. F in a compound is -1. F by itself is 0. F2 is 0 as well, a diatomic element, one of the Brinkelhoff series. The oxidation number of each oxygen atom in most of its compounds is -2. So usually oxygen's -2. When it combines with fluorine, it's typically positive, usually +2. And in peroxides, such as hydrogen peroxide, that's what you find in your bathrooms you clean wounds with, it's -1. So for all of these, oxygen is going to be -2. When it hooks up with 2 fluorine atoms, it's +2. We're not going to play with that very much. I'm not concerned there. But in a peroxide, in a peroxide such as hydrogen peroxide, sodium peroxide, these look funny as if you forgot to reduce, but you didn't. The O is going to have a -1 oxidation number. And we're going to use all these rules so you're going to see it. In compounds, group 1 and 2 ions as well as aluminum ion are going to have oxidation numbers of +1, +2, and +3. That's the charge they would form if they were ions by themselves. So sodium fluoride, lithium chloride, cesium oxide, sodium ion, lithium ion, cesium ion, these are all going to have oxidation numbers of +1. They're in group 1. Calcium fluoride, barium oxide, strontium chloride, these are all in group 2, oxidation number of +2. An aluminum containing compound is going to have an oxidation number of aluminum of +3. So taking these rules, let's work through these together. The first two, we can just do them all on paper. So the first one we have is zinc. Zinc is going to have an oxidation number of 0. Free element. Iodine diatomic element will have an oxidation number of 0. The next example is this. Which is more electronegative, H or S? S. If S was by its lonesome, what would its charge be? 2 minus is correct. Therefore, the oxidation number of sulfur is -2. In addition, if you start a compound with H, H is going to be +1. I'm going to hold on 4 and 5. Four and 5 don't really belong in this example listing, so I'm going to take them out. The next example is magnesium. Peroxide. Sneaky, sneaky. How did I know that wasn't magnesium oxide? How would you formula write magnesium oxide? Magnesium's in group 2. What's its charge? Oxide is 2 minus. So magnesium oxide would be this, right? Remember I said peroxides almost look funny? Where this came from is you have magnesium 2 plus and peroxide 2 minus. So those 2's that you swapped and dropped canceled. I want to know the oxygen in a peroxide. Oxygens are typically -2, but in a peroxide they are -1. Sneaky, sneaky. The next one, why is H not +1 here? This is an example of a hydride. So in a hydride, H is -1. And lithium compounds, lithium group 1 is always +1. The last example there is a strontium ion. What would its oxidation number be? +2 is correct. So that's just some basics to get going. And now what we're going to do is we want to determine the oxidation number of each element in the following compounds. Here's the key rule to get it going. It says the algebraic sum of the oxidation numbers for all atoms in a compound, taking into account how many of each you have, is 0. It says the algebraic sum of the oxidation numbers for all the atoms in a polyatomic ion, taking into account how many of each you have, is equal to the charge on that ion. And I'll show you these rules together. So we're just going to walk through all of these examples now, and then you're going to need a lot of practice. Here we go. I'm going to walk through it very slowly. The first example is potassium permanganate. I gave you the name. You have to be able to write the chemical formula with ease. I told you by today you needed to be able to write chemical formulas with ease. Typically, when you've got an ionic compound with more than 2 atoms, you typically don't know what the middle one is because it has the ability to form multiple oxidation states. Potassium is in what group? 1. And group 1 elements in a compound always have what oxidation number? +1 is correct. Oxygen, unless hooking with fluorine or a peroxide, will have what oxidation number? -2. Look at your rules. We're trying to figure out the manganese. Now, manganese is a transition element that we already know can form ions of multiple charges, also can have multiple oxidation states. Here's my approach. I have 1 potassium with a +1 oxidation number. I have 1 manganese, that's what I'm looking for. I have 4 oxygen, each with a -2 oxidation number. I'm going to set that equal to 0. I have 1 plus manganese minus 8 equals 0. I have manganese minus 7 equals 0. The oxidation number for manganese is +7. That's the missing one. Baby algebra without a calculator, slow and steady. The next one is calcium oxalate. And the first thing you have to be able to do with ease is write the chemical formula. And again, you should be able to do that with ease at this stage of the game. You had more practice in class on Friday, and classwork 2-1 should be done. If it's not done yet, it needs to be done by tomorrow. Calcium is in what group? It's in the second group. Its oxidation number is +2. Oxygen typically -2. We're looking for the carbon, and carbon has the ability to form multiple oxidation states, including 0. Be careful with carbon. Calcium has an oxidation number of +2. We're looking for carbon, but we do have 2 carbons. We have 4 O's, and again, my oxidation number is going into parentheses. What's outside the parentheses is how many of that atom we have. The algebraic sum for the compound, which is electrically neutral, is 0 for oxidation numbers. 2 plus 2C minus 8 equals 0. 2C minus 6 equals 0. 2C is equal to 6. Oxidation number of carbon is +3. Now I want to show you a trick. I think it's actually easier. I think you will as well. I'm going to go back up to the first example. If I'm going after the oxidation number of manganese, I can isolate that polyatomic ion. Permanganate ion has a charge of 1-. I can go after the oxidation number of manganese based on the polyatomic. I have 1 manganese. I have 4 O's. This should be a plus. Oops. The sum of the oxidation numbers, oxygen, -2. The sum of the oxidation numbers for a polyatomic ion is equal to the charge. I'm going to set that equal to -1. Manganese -8 is equal to -1. Manganese in a permanganate ion is always +7. So you can do it either way. Whatever makes you happy is fine with me. Just make sure you do it right. I like the ion only. You can see it on this one as well. Oxalate ion has a 2- charge back of the periodic table if you don't know them. You have 2 carbon, 4 O's that are -2, and what would you set the sum of these equal to? -2, the charge. And you have 2C minus 8 equals -2. 2C is equal to 6. C is equal to +3. So you can check your work or you can just do it off that. Whatever floats your boat is fine. We're going to do a whole bunch, so if it looks like Chinese, don't panic. Of course. All right, this one I need you to talk me through a little more. We've got aluminum sulfate. Again, the formula writing is absolutely critical. Aluminum containing compounds, aluminum always has what oxidation number? +3. Oxidation numbers are plus or minus, followed by the number. Charges are numbers, then plus or minus. Careful, careful. Oxygen in a compound that's not a peroxide or one with fluorine has what oxidation number? -2. We've got 2 aluminum +3. Be careful here, distribute. 3 S's, that's what we're looking for, typically looking for the one in the middle. 12 O's, 3 times 4 is 12, times its oxidation number of -2, set equal to 0. 6 plus 3S minus 24 equals 0. 3S is equal to 18. Sulfur in a sulfate ion is +6. And again, you could check it off the sulfate ion if you prefer. You've got S plus 4 O's at -2. What would you set that equal to? -2. And so S minus 8 equals -2. S is equal to +6. So it checks, similar to checking your work back in pre-algebra. Number 4 says sodium perchlorate. What's the oxidation number for sodium in a sodium-containing compound? +1, because it's in group. We're looking for chlorine. Don't get confused here. You never see CiO. This is a perchlorate ion hooking with the sodium ion. Oxygen is typically what? -2, oxidation number. Looking for chlorine. We have 1 sodium. We're looking for chlorine. How many O's do we have? Oxidation number of oxygen, -2. We set it equal to 0. Try and solve it. What'd you get? +7, right? Chlorine can go -1, 1, 3, 5, 7. If you wanted it off the perchlorate ion only, you'd have chlorine plus 4 times -2. What would you set this equal to? -1 is correct, and chlorine would be +7.
Is that way easier? It looks a lot shorter.
Yeah, it is. I think this is much easier, especially on one like this. This one's very tricky. This one says lead 4 phosphate. What's the oxidation number of lead in a lead 4 phosphate? Don't look at the periodic table. It's not going to help. It would be 4, right? So once you know the Roman numeral, you know the charge, you know the oxidation number. The oxygen's -2. And Gavin wants to just do the ion because he says it's easier, and he's right. Phosphate, you're looking for 4 O's times -2. What do we set that equal to? Phosphorus in a phosphate ion is +5. The next set is backward. But again, no more difficult than this set. In some cases, it's easier because I give you the chemical formula. Let's take a look. This is what's given. Raise your hand and name that compound carefully. Go ahead, Will.
Copper nitrate.
Missing something.
Copper 3.
Don't listen to your friends.
Copper.
So remember, just like we did the other day, if there are no parentheses there, put an imaginary set in. So you'd have 1 nitrate grouping, that's copper 1 nitrate. So if it's copper 1 nitrate, what's the oxidation number on copper? +1. Oxygen, typically -2, looking for the N. Nitrogen has the ability to form multiple oxidation numbers, as do your transition elements, as do your nonmetals in the P block. So what you're looking at here, copper's +1. We're looking for N. We have 3 O's, and we're going to set this equal to 0. 1 plus N minus 6 equals 0. N is equal to +5. If you only went after the nitrate ion, what's the charge on nitrate? One minus. Looking for N. We have 3 O's at -2, set equal to -1. N is equal to +5. Alrighty? This one is very tricky because you have a lot going on. I won't give you anything this difficult, but you could do it anyway. This is ammonium sulfite, so you have more than 3 atoms here. When N hooks up with H, we saw this initially, the N is -3, the H is +1, the O is -2. You're looking for the sulfur. Give it a try. Or if you want, go after a sulfite ion. It'll be easier. Give it a shot. What'd you get for the S? I got +4 as well. This one's also very difficult. I'm going to write it down the second way it's written because it's a little bit easier. This is lithium acetate. You don't know the C. That's what you have to look for. And then I also want you to try and do this one. Be very careful. And the ion in the next section, a cyanide ion. I'd like you to try these three. If you want me to walk you through, I will, but I think you could give it a shot. What'd you get for the first one? Did you get 0? Good. I don't want you looking at all my work right away. You gotta try. What'd you get for the carbon in the carbonate containing compound? Did you get it? What'd you get? What'd you get? Sam, what'd you get? Okay. So just say I'm not ready. All right, what'd you get, Sam?
Good afternoon, Cobras. Please listen carefully to the following announcements prior to Vista Venom striking now.
That's what I got.
Attention students, if you want to wear a costume tomorrow on Halloween, you must purchase a pink wristband for $1. Wristbands will be on sale in the courtyard during lunch today and tomorrow morning. Students also remember you must follow
Is that what you got?
Park dress code when choosing your costume. Girls basketball tryouts will be held this evening at 6 p.m. in the gym. Make sure that your athletic packet is turned in prior to showing up for tryouts. Any questions? Ask Coach Macri in 4210. Teachers, at this time, please turn on your computers and prepare for this afternoon's video announcements. This venom strikes now.
Did you get this one? Yes? Did you get that one? That's a sneaky little one.
Where do you find, where's that question?
Oh, that was, I wrote it here, but it's in the next section. It says cyanide ion. It's a little unusual, so I wanted to show it to you. I'll give you your classwork now. The beginning part is naming and formula writing and then oxidation number. We are going to take tomorrow's class period to work on it and just talk a little bit about the properties of ionic compounds, which will take maybe 5 minutes. Most of tomorrow's class will just be practice, 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 and I think that will solidify it for you. Your quiz won't be till Thursday because I want you to be able to trick or treat on Tuesday night without worrying. I'll give you your classwork now, but we're going to work on it in class tomorrow. If you didn't finish 2-1, I recommend it. Oxidation numbers are very, very tricky. We introduce them here and they come into play in great detail at the end of the year. But what you want a very high comfort level with is writing chemical formulas and naming ionic compounds.